All right, so some trig ratio questions here. Interestingly, we've got to find exact values. I'm excited because I like finding exact values. It's one of the more fun things we do in maths. There are quite a few, of course. But what do we notice here? Well, they're all angles inside right-angled triangles. So even though way over here I have my best friend in maths, the unit circle, just itching to be used for these. Remember, unit circle, it's got a radius of 1, so you can see the intercepts there. Label my axes while I'm at it, why not? This is the cosine of the angle. This axis shows me the sine of the angle because at any point on that circumference, the x-coordinate is the cosine of theta, where theta is this angle. Measured, of course, from 0 degrees in the positive x-axis direction. And sine theta is the y-coordinate. I have that there waiting to tell me the first step. Are my values positive or negative, depending on what quadrant the angle's in? Not needed. We're always in the first quadrant because we've got right-angled triangles, so none of my angles are bigger than 90 degrees. But they're still asking for exact values, which means we've got to pull out our best friends' little buddies and put them to work. So the 30, 60, 90 triangle. Smaller side, opposite the smaller angle. The hypotenuse is the biggest number, which was 2. And 60, it must be root 3 that goes there. You check it with Pythagoras. 2 squared is 4. Root 3 squared is 3. Plus 1 squared is 4 as well. So 4 equals 4. We know we've got them in the right place. Other best friend's little buddy. Isosceles triangle. An isosceles right-angled triangle always has the hypotenuse exactly root 2 times the size of the side length. So we just arbitrarily choose to call the legs 1, and then the hypotenuse becomes root 2. Again, you can check it with Pythagoras. What does that mean for question A over here? Well, I've got an opposite side and a hypotenuse here, don't I? Remember, step 1, label the sides. Now I go ahead and choose the appropriate rule. I need the opposite and the hypotenuse. Where do I check? SOHCAHTOA. That's where I go to check which ratio I need. I've got the opposite and hypotenuse, must be the sine ratio. So I write the sine of 45, the opposite side was x, the hypotenuse was 6. Oh, well, to get x on its own, got to get rid of that 6. Opposite of dividing is to multiply. So I've got 6 sine 45 degrees is equal to x. Exact value, I go over here and I check the sine of 45. Sine of 45 is 1 over root 2. So this would be 6 multiplied by 1 over root 2 equals x. We could, of course, write that as 6 on root 2 equals x. And you wouldn't leave it like that because that's just rude. Rationalize that denominator. This 2, root 2 on root 2, I left off the root there, look at that. Root 2 over root 2 to rationalize the denominator. So it now becomes 6 root 2 over 2. Oh, and I've got more cancelling I can do. That 2 goes into that 6 3 times. So 3 root 2 is equal to x. Yes, you could take a few liberties and maybe simplify or leave out 1 or 2 of those steps, but you would write your answer as 3 root 2 because that's just the most polite way to write the exact value. Oh, look, the next one's a 45-degree triangle as well, and they've given you a side length and the hypotenuse. It was the adjacent. It'll look almost identical, except it will say cosine instead of sine. Let's skip that one. Let's go on to one of these ones. Oh, look here, let's have a go at C. I don't want to do them all. C, what have I got? Well, I haven't got the hypotenuse. I'm looking for the opposite side, and I know the adjacent. Opposite and adjacent come from TOA, the tangent ratio. So here I write the tan of 30 equals the opposite side is x over the adjacent side is 20. Want x on its own, so I multiply by 20. 20 tan 30 equals x. Okay. Let's replace tan 30. That is an exact value, but tan 30 can be written in a more beautiful way than just tan 30. So I go to the tan of 30 and it's 1 divided by root 3. Opposite over adjacent. So the ratio for tan 30 is always 1 on root 3. you, of course, remember that you need to rationalise that, multiplying by root 3 over root 3. I get 20 root 3, and the root 3 times root 3 on the bottom becomes 3. Equals x. Did I go too quickly for you there? What was I doing? I was multiplying by root 3 over root 3. So I ended up 20 times 1 root 3 is 20 root 3, and root 3 by root 3 in the denominator becomes 3. That's your answer. Oh, any others we want to do? Oh, yeah, let's have a look at f. I think it's going to be different because we might have our variable on the bottom. What sides have I got? I've got my hypotenuse. This is my opposite side because it's across the triangle from that angle. That would be my adjacent, but I need the opposite and hypotenuse. Sine rule again. Sine of 30 equals the opposite side, 1.5, divided by the hypotenuse x. Okay, don't like my x being on the bottom, so I multiply through by x, and I've got x sine 30 equals 1.5. I want x on its own, so the opposite of multiplying by sine 30 is to divide by sine 30. 1.5 divided by sine 30. What is the sine of 30? Go to your best friend's little buddy. Opposite side, 1. Hypotenuse is 2. So this is actually 1.5 divided by 1/2. Well, dividing by 1/2 is the same as multiplying by 2. So x would equal 3. And you're done. I'll leave you the other 3 to do, but I think you got the hang of it now. I hope that helps. Cheers.